All right, so we're looking at two limits today, problems m and n. And the first thing we notice is that both of these are limits to infinity, as we can see. And then a second similarity between these is that they both have polynomials. On here, both the numerator and the denominator are polynomials, whereas on the second limit, only the numerator is a polynomial. So it leads us to a major difference in the two is that the second limit has an exponential at the bottom, so the leading terms are not all polynomials. And a second difference is that this one has a square root, which means that we have to reduce this one in order to get our answer. So let's start by solving our first limit. So the first thing we need to do is recognize what our leading terms are, because these will determine whether the numerator or denominator will go to infinity. So our leading term on the numerator is 2x squared. And then our leading term here is the 9x to the fourth. But because this is within the root, we need to find a way to reduce that. So this limit is equal to the limit as x goes to infinity, and we just leave the numerator the same. And then for the denominator, we're going to square root all of these parts. And we can just focus on the leading term in the denominator because the other ones don't have an impact on the end behavior of our denominator. So 9x to the fourth, the square root of that is 3x squared. And then we can apply a similar logic up top with the numerator. So our new limit is, the limit as x approaches infinity, of 2x squared over 3x squared, because again, these smaller terms don't really have a major impact on the numerator going to infinity, or of the speed of the numerator going to infinity. So then we have the limit as x goes to infinity of 2x squared over 3x squared, and we know that the x squareds cancel. This leaves us with the limit as x goes to infinity of 2/3, which is simply equal to 2/3. So that's the answer. So when we have two of the same kind of function, in this case powers, and they're raised to the same power, we can just cancel those out, and the limit will converge to a single point instead of diverging or converging to 0. Next, let's take a look at the second limit here. So in this limit, again, we want to identify our leading terms. In this case, we pick our highest power, which is -5x to the fifth. And then on here, we have 5x to the fifth, but we also have this exponential. And we know that exponentials grow faster than any powers. So this is our leading term here. So this limit is equal to the limit as x goes to infinity of -5x to the fifth over -7 2 to the x. And so, as I mentioned, the bottom is going to go to infinity faster than the top. And when this is the case, we don't care about the coefficients here, because essentially at some point the bottom will be infinity and the top will be finite, and any finite number over infinity is going to get us 0. So this limit, because the bottom function approaches infinity faster than the top, is equal to 0. And so there was a different way that we evaluated these two functions, so these two limits, because in this one we actually had the terms cancel out, and in this one we just had to evaluate the behavior of the functions as they went to infinity.